I want to begin this video with a thought experiment. So let's imagine that we've got a basking bulb, which for sake of argument, we'll say is an incandescent or halogen lamp, although it could really be any lamp. Imagine that you take this bulb out to the desert and put it somewhere in the shade, so perhaps you set it up at the evening time. Then what I want you to do is imagine that you put a thermometer a set distance from this lamp, leave it for a set period of time and record the temperature. Now imagine that you do this instead of in the desert, like in the Sahara or something, you do it in Antarctica. So in which scenario are you going to record the highest temperature? Well, obviously in the desert, right? Because the air is warmer. But the important thing here is that the lamp in both scenarios was identical, and the distance between it and the thermometer was identical, and the length of time that we left the thermometer to warm up was the same in each case. In other words, the effect of the lamp on the thermometer would have been identical in both situations. The difference in the temperature recorded by that thermometer was due to the environment around it. Now, the standard practice in reptile keeping is to set up a basking zone with a thermometer and alter the output of basking bulbs in order to get that thermometer to read a desired value. So what you might do is put a lamp on a dimming thermostat and put a set point on it so that the lamp dims up and down in order to get the right temperature. Or you might just go about changing the lamp to one of different wattage. So if the temperature you're reading is too high, you might go from a 50 watt to a 30 watt or something. And in so doing, you maintain the right reading on this thermometer, but you alter the output of the lamps at basking zone. Now, the argument that I'm going to support here is that we shouldn't be doing this, and instead we should be controlling the output of lamps separately to the temperature in the enclosure. So if we jump back to the thought experiment for a second, if we were to have an enclosure with the same reptile in it, in the desert or in Antarctica, then the lamps that we should use in that enclosure are the same in both scenarios. So even though in Antarctica that enclosure is going to be a lot colder, we shouldn't start increasing wattages and reducing the dimming state of a lamp just to get the temperature higher. We should leave the lamp still, because the lamp will have been chosen for the animal in that enclosure in order to give the appropriate output or the radiative output of the lamp. And instead we should moderate the temperature using other means. Or to actually put that into a real world scenario that matters, if we have an enclosure in a warm room and a cold room, well, the lamps we should be using in it for a particular species are the same. And we should be focusing either on ventilation to cool the enclosure down in the warm room, or other forms of supplemental heating to warm it up in the cool room. We set the radiation at the basking zone and worry about the temperature after. Now, that probably sounds like an alien concept, but it really shouldn't, because it's what we all do with UV lighting for reptiles already. So you pick a lamp that will provide the correct ultraviolet index at the basking zone, with the ultraviolet index just being a quantification of the ultraviolet radiation that is being provided at that basking zone. And then after you've got that set up, you moderate the temperature in the enclosure without thinking about the UV lamps at all. All I'm saying here is that we should be doing that with all of the lamps that we use. So having gone through that rather long introduction, I'm going to split the rest of this video into two parts. The first being replicating sunlight or setting up the correct radiation, which means getting the right lamps in the enclosure. And then for the remainder of the duration of this video, I'll talk about controlling temperatures and what temperatures actually mean for reptiles. So in terms of setting up the right radiation, what we want to do is replicate those sunlight conditions to which our chosen reptile species would expose itself to in the wild. Now, because we don't have a single type of lamp that can replicate all of sunlight, what we need to do is take the sunlight spectrum and split it up into different sections, then reproduce these sections using different lamps. The three chunks of the spectrum that matter to us are ultraviolet, visible light, and near-infrared. Near-infrared is that part of the spectrum which includes infrared A and infrared B, but not infrared C. And recently there's been a bit of a trend in the reptile hobby to start talking about this more. So, as I said earlier, doing this for the ultraviolet part of the spectrum is already fairly commonplace, and to risk repeating myself, what you do is you pick a lamp that is going to provide the correct UV index at the basking zone for the animal that you're keeping. And this is common practice now, there's plenty of information available about it online, but I'm just restating it to point out that what I'm going to suggest for visible light and near infrared is basically the exact same as this, only with different parts of the spectrum. So if we turn our attention towards visible light, well, pretty much every lamp that you're going to put in an enclosure offers some amount of visible light. And for a species which tends not to come out towards the middle of the day, so something like a corn snake or a leopard gecko, then you probably don't need to worry about visible light any more than this. But for something like a bearded dragon or a day gecko, which does bask in full sunlight, then you do need to pay a lot more attention to visible light. Now, instead of the UV index, for quantifying visible light intensity, we can use lux, and that is really useful because lux meters, you can buy a decent one for 20 quid, so this is a really easy measurable thing. And what you want for a sun worshipping species is a lux of like at least several tens of thousands at the basking spot, no more than 100,000 definitely, about 50,000 seems to do it. And in terms of actually achieving this, then one bit of kit that you can use to do it, which I tend to use, is just a spot LED, something about 40 watts. And of course, as with any other lamp, you want that to be illuminating in an area which is big enough for the animal to fit under. So why this stress on visible light? Well, people do tend to write it off because they think visible light, oh yeah, it's just for seeing, visible light doesn't do anything. But this simply isn't true. So it's like somewhere between 40 and 50%, I think, of sunlight. The energy that is being received when you are in sunlight is in the form of visible light. So for a basking reptile, that has a significant effect on warming it up. So it's not just stimulation, it's actually warming that animal up. And it also has other physiological effects which we are only just beginning to understand. So it's something that you really cannot skip. So the third and final part of the spectrum that we've got to consider is near infrared. Now, the best lamps in terms of composition for providing this radiation are incandescent lamps, or even better still, halogen lamps. There are other types of lamps with carbon filaments that are advertised as being the best at replicating near infrared, i.e. infrared A and infrared B, but this isn't really the case. It's the old-fashioned types of lamps that are the best. Now, unfortunately, we don't have something like the UV index or lux to quantify near infrared, and me and Roman Murin and some other people who've been involved have spent a lot of time thinking about what we might do to quantify near infrared. And to say it really quickly, because I'm going to glance past it for this video, you can use meters that are made for registering the whole spectrum of sunlight. And these give a convenient output which happens to tally in nicely with infrared A when used with the lamps I've just talked about. And then if you're using that, you can aim for a reading of about 300 watts per meter squared. Now that sounds like a lot of scientific jargon if you don't understand it already. And honestly, the meters are quite expensive, so it's not even really that accessible. And for this video then, what I'm going to tell you is a practical method which works. Sounds ramshackle, but it does work and it is safe. So take it with a grain of salt. There are definitely better ways of doing this, but this is practical and it works, so you've got to accept a middle ground at some point. So what you're going to do in this practical method is set up the basking zone and just pick a lamp to begin with, which is like your first guess before you iterate towards a better model. Now, a good first guess for a basking zone, which is about 30 centimetres from the base of where the lamp finishes, is something that's about 50 watts, and you want something that's more strongly reflected for something that basks in the middle of the day, like a bearded dragon, so a par 20 halogen lamp might work for this, whereas for something like a leopard gecko, which doesn't bask in such intense sunlight, then something like a pearl bulb with a reflective sleeve tends to be better. Now what you want to do once you put this lamp in is just put your hand at the basking zone with that particular lamp on, and leave your hand there ideally for like a full 5 or even 10 minutes, and just see what it feels like. It should just be the most gentle thing ever. It doesn't feel hot in the slightest, just really gently warm. Now that is where this method sounds ridiculous. It's like, what, you're just using your hand to measure the intensity of radiation? Hello? But you would be surprised at just how sensitive your hand is. In any case, if you've set up a basking zone which is as I've just described with a very slight feeling on your hand, then I think anybody watching this video will be happy to accept that that at least proves that the basking zone is safe in that it's not going to burn the reptile. Now, if you've done as I've just described, then you've actually probably set up a decent system just in one fell swoop. But my recommendation then is just to take cues from the reptile. So if you see that it goes right under the lamp and is basking all the time, then it's probably that the radiation isn't intense enough, and so you should either increase lamp wattage or increase the degree of reflection. Whereas if the reptile tends to avoid the light, then it's probably too intense, and so you should do the opposite, i.e. reduce wattage or reduce reflection of the bulb. So after a couple of tries with maybe 2 or 3 different lamp types, you should get something where the animal chooses to sit right in the middle of the beam, and then will move out after like 10 minutes, which is ideal basking behaviour. Again, it sounds a bit imprecise, but it actually works really well, and if you take readings with the meters I described earlier, then the values that you get are perfectly sensible to sunlight, i.e. below that 300 watts per metre squared value. So after you've done that, you have done about as good a job as you can do in terms of replicating sunlight. With the technology we've got available, that is pretty much all that you can do in reptile keeping, and it's a decent job. So now then, we're going to turn our attention to looking at temperature. So what actually is temperature, and why is it important to reptiles? Well, temperature is just a measure of how hot something is, which in turn just tells you what capacity it's got for giving heat energy to other things. Now, reptiles don't have metabolic control of their own body temperature for the most part, and instead to control it, what they do is move about in their environment to interact with radiation from the sun and also different objects and the air in their environment, which has its own temperature and can moderate the body temperature of the animal. So the traditional approach to lighting and heating a reptile enclosure is to set up a basking zone where a thermometer reads the same temperature as is roughly the peak body temperature of the reptile inhabitant of that enclosure. So for example, for a bearded dragon, which might have a working body temperature in the upper 30 degrees Celsius or something, then you aim for a basking zone which has a temperature of like 35 to 40, or for a leopard gecko, something about 30 degrees, right? Well, the thing is, this is flawed in as much as what the reptile has evolved to do is moderate its own body temperature through its behaviour. So what we should be doing is not controlling something to the animal's peak body temperature, but rather setting up an environment that allows the animal to do it itself. This, of course, includes replicating sunlight, which I've already described, and then setting an ambient temperature that is just comfortable for the reptile. What I mean when I say that we want the temperature to be comfortable is that the temperature of everything in the enclosure should be in an appropriate range so that it's not too hot for the animal or too cold. We don't need to worry about getting exactly precise temperatures anywhere. Now, the most important temperature that you can consider in the vivarium is just the ambient air temperature, which can be measured with a probe or even an analog dial thermometer and placed far away from any lighting. Now, the reason that this is important is that it is what the animal will experience for the majority of the time that it is not basking, and so it encapsulates, together with the radiation conditions at the basking zone, how the animal is able to control its body temperature through its behaviour. The ideal ambient temperature range that you can provide is what you're going to find by looking at weather data relevant to the native range of the species that you are keeping. And of course, this is going to change with the time of year as well as just the location. If you find that the ambient temperature in your enclosure is too low, then you can increase it using thermostatically controlled heating devices like heat mats or ceramic heat emitter. And if you find out that the ambient temperature is getting too high, then you have to reduce it using increased ventilation. So cut more vents or even put fans on the enclosure. What you don't do is start thermostating your lamps. Well, I will allow one exception to this. So if you've got all your lighting set up and it's running full tilt, again to provide the appropriate radiation, then what you might want to do is run it all through an on-off thermostat with the probe putting the ambient temperature measuring position, so away from any of the lighting, and set it to like a high value, so maybe 35 degrees or even 32 degrees, something a bit lower, something like that. And then if it reaches like a really hot emergency condition like that, where if it gets any hotter it's going to like seriously harm or even kill the animal, then that on-off thermostat is going to cut all the lamps off, and that's like a fail-safe. But the point is there, it is just a fail-safe cut-off. You are not controlling the temperature through controlling the output of lamps, which are there to offer radiation, not temperature. With that said, it is definitely a good idea if you can set up the enclosure as it's going to run at a time of the year when it's really hot, and just leave it running 24/7 and see what sort of temperature values you're getting. And if they are getting dangerously hot, then you should put measures in to prevent that, so cut more vents basically. Don't worry about cutting too many vents because it's easy just to block them up after. But basically this fail-safe testing is ensuring that the enclosure is properly designed, and really this should nullify the use of any thermostats for the lighting. And that's it, I think.